Welcome to section 3.2. Now, this is the second half of two sections in chapter 3 that deal with solving linear equations. Now, the nice part about this is that by the time we finish this particular section, you will be able to solve any type of linear equation. Now, some of you may have taken Common Core. Well, there is a little phrase, just like when we solve order of operations, that have come into being. Now, sometimes people like the expression, sometimes people don't, but it helps a lot when you're trying to decide larger or longer linear equations. Now, I like to use it because it has been one that I found gives you an order of which to solve a linear equation. And whether you like the saying or not, sometimes it's easier to just show you how the statement or acronym or phrase works, and then you can decide whether you want to use it or not. Now, this is the acronym or phrase. It says, David, can Aunt Susie or Aunt Sally make dumplings? Now, in section 3.1, we solved one-step and two-step equations. Well, the one-step put Aunt Sally together where we added or subtracted, and then we also had multiply or divide, which was another type of one-step equation, and then we put them all together, which means we did Aunt Sally makes dumplings, where you add or subtract first, and then you multiply or divide to get the variable by itself with a positive 1 coefficient. Well, now we're going to add a few more pieces. Now, the David is one that we're going to hold off a little bit with because that has 3 different phases to it. But this is how the phrase works. Now, this sheet you might want to print out so that you understand the process. Now, whether you use it or not is up to you, but the first one says David. Now, this represents 3 different steps. It can be the distributive property, the denominators of fractions, it can be decimals, or it can be a combination of those 3. And then we have can. Now, we talked about that. That's where we combine terms on the left side and then on the right side. We are not crossing the equal sign because that means we're not changing signs. Now, here's where the fun part comes in. You remember in 3.1 that we had a lot of terms on one side of the equation, and we combined all of the variables. But all of the variables you were given were on one side of the equation. Well, that's not going to happen anymore. That's where Aunt Susie comes in, because our variable terms are going to appear on both sides of the equal sign. Now, when that happens, you are moving the variable terms across the equal sign, which means we're adding and subtracting. But there's a little catch. Now, I prefer that this work, and you're going to find that I always do it, but you want one variable term on the left of the equation. Then we're going to go to where we were working. We're building on what we learned. This is Aunt Sally. This is going to deal with the constants or numbers. And again, we're moving it across the equal sign, and we're adding and subtracting. That's where the AS comes in. You add or subtract. But here's the catch. We want to find one constant on the right side of the equal sign. So you want variables on the left, numbers on the right. Now, the reason for the little or in the middle is that some people like to do the numbers first before they do the variables. Well, that's okay. That's why it's or. You're going to make a choice. Do you want to move the variables first and then the numbers? Or do you want to do the numbers and then the variables? But you have to remember you want the variables on the left and the numbers on the right. This is probably the easiest way to get you to solve an equation. Now, sometimes some of you may differ with me and want the variables on the right and the numbers on the left. Well, that's still okay. But you're going to find that sometimes by putting the variables on the right and the numbers on the left, you're going to have a negative coefficient of the variables. Well, that's your choice. But you're also going to find we have a negative coefficient for the variables on the right as well. But this is my choice. And again, you can deal with this one way or the other. And if you get it wrong, you might want to come back here and take a look. And then the last thing that we're going to do is make dumplings, which means the very last step you ever want to do in a linear equation is to multiply or divide so that you get a coefficient of +1. Now, I'm going to use this acronym throughout, and I'm going to show you how it works. Now, with mathematics, there are many different variations. As long as you get it right, I'm happy, because mathematics, we all come out with the same answer. But if you're coming out with a different answer, you might want to think twice. Okay? Now, this is what we're going to start with. We're going to start out with the combined Aunt Susie, Aunt Sally make dumplings. We're only going to work with these parts at the beginning, okay? Then we're going to add in the David, which we'll talk about in a moment. But using just this 4, here we go. Now, my equation is 2v plus 15 plus 3v equals 3v minus 10. Okay, these are how the acronym works. Can. Okay, combine terms. Well, what that means is I'm going to go to the equal sign. And notice I have 2 variables on the left of the equal sign. I am combining them. I'm not touching the 3v on the right. I'm just combining them. Well, this will give me 8v plus 15 equals 3v minus 10. I've just combined terms. Now, here's the fun part. Aunt Susie. Now, we're going to add or subtract the variable terms. Well, that means this 3v and this 8v are going to go to the left-hand side. I've got them on both sides. So what I'm going to do is I am going to subtract 3v from both sides. That's how Aunt Susie works. And this will give me 5v plus 15. Now notice there's no more v's on the right. I only have one v and it's on the left. And this is equal to negative 10. This is where we started in section 3.1. We just have these two new steps that we're adding. But it's knowing to do those first. Now the fun part. Aunt Sally. We're going to add or subtract the numbers so they're on the right, which means I'm subtracting 15 from both sides. This is going to cancel. This will then give me 5v equals negative 25. And then I make dumplings, which means I multiply or divide. I am dividing by 5 because this v has got to have a positive 1 coefficient, and this will give me negative 5. Now, v is equal to negative 5, or as I told you, sometimes they like to write the solution set by saying v is equal to the set of negative 5. This is how the acronym works. It tells you how you begin and how you end. Okay, let's try another one. Okay, now this one is going to introduce David. Now, we're introducing David because we have to deal with the distributive property. That's one of the catches. Now, you have to remember, in front of this parentheses is a negative 1. Okay, well, let's continue. Let's get rid of the parentheses. This is 10m plus 13 minus 4m. Now remember, this is positive 5. Negative times negative, and this is giving me m plus 3m plus 21. This 3 is distributing. Now, this is where we're going to start to get real nice equations. Combine terms. Well, this 10m and this negative 4m on the left side of the equation are going together, and they are going to give me 6m. But I have a positive 13 and a positive 5. They are still on the same side. This is giving me positive 18. Now notice, I've only worked on the left side of the equation. Well, now I'm going to go over to the right side because I'm still going to combine terms. I am going to take this m and this 3m, and I'm going to put them together. I'm still combining terms. Now this will give me 4m plus 21. Combine terms. Lots smaller than what I started with in the step above, but I knew what to do in the order of which to do it. Now, step 3. We're going to add or subtract the variable terms. Now that means this 4m, I am going to subtract 4m from both sides. Now this will give me 2m plus 18 is equal to, now notice these cancel out, positive 21. Well, we're now down to what we did in the two-step equations that we did in section 3.1. What we did above was the new stuff. Now we're just building on it. We are going to subtract 18 from both sides. This will give me 2m. These are canceling out, and this is a positive 3. I am going to finish by making dumplings. I'm dividing by 2. M is equal to 3 halves. Now, I don't want to write 1 1/2. The reason is it's just asking me to solve. In algebra, an improper fraction of 3/2 is correct. But you can also find that they're going to put in a solution set 3/5. It depends on how they ask you. They're normally McGraw-Hill likes to put it as a solution set because it's the only answer. So you can say m is equal to 3 halves, or if they give you the set bars, it's 3/2. Huh? Now, notice how this helps me solve it. Well, we're going to try another one. Okay. This is using the distributive property. Now, I want you to notice this third equation and our second equation just had parentheses and everything else had whole numbers. Well, that's going to change in a minute, but we're going to deal with just whole numbers. Well, when I distribute, this gives me 7y plus 2 minus 8y. This 2 is multiplying by negative 4y, and this is equal to 8y minus 5y minus 20. This negative is multiplying by positive. Now, please, I know that you see a negative 8y on the left and a positive 8y. Do not cancel them out, because our next step is to combine terms, which means 7y and negative 8y are going to give me a negative y plus 2. On the right side, 8y minus 5y is 3y minus 20. Now, this is a perfect situation of this third step. Now, I like to get the variable terms to the left. Now, that means I add or subtract. Well, I am going to choose to subtract 3y. This is going to cancel, and I'm going to get a negative 4y plus 2 is equal to negative 20. Now, someone said, couldn't I bring and add a positive y to the 3y? Yes, I could, but that is going to do the opposite. It would bring the variables to the right, but then I have to ensure I bring the variables to the left, the numbers to the left. I like to be consistent. Some people say I have OCD, obsessive compulsive. I do one thing one way. Well, when you start working and learning this, it's easier to follow a pattern because you want to get it right. As you get more sophisticated in mathematics, you can make some adjustments, but you have to understand what you're doing, and this helps you get started. Now, we're going to then subtract 2. Well, this will give me a negative 4y is equal to a negative 22. Now, the final thing is I'm going to make dumplings, which means I'm multiplying or dividing. But remember, I need a positive 1 coefficient. Well, that means I'm dividing by negative 4. Well, this will give me y. Now, right here, a negative divided by a negative is positive. Do I have to write the positive side? No, but the fraction, 22 over 4 reduces. You have to reduce, which means if I divide by 2, it's 11 over 2. This is what my y value is. And again, sometimes they like to put it in set symbols, but the answer, if it's a fraction, must always be in reduced form. Any questions? I hope not. Because now we're going to get into some good stuff. Okay. This is something that you don't learn until you start taking 481 and move forward. Some of you may have been introduced to this, but we're going to go with it. Okay. This is going to talk about the David part of my phrase. Now, as you remember in earlier slides, the D represented 3 things. We've been using it to eliminate parentheses. That's the easy part. Well, now we're introducing 2 other parts to this. Now, you're going to either do first, eliminate the fractions. Now, this is something you may not have done before. Now, if you took 461, toward the end of the course, I do show some of my students how to do and get rid of the fractions. And you want to know that you're multiplying each term. And that's the catch. People don't remember its term within the equation by the LCD. This is going to get rid of your fractions. Get rid of fractions. That's the first step. If you have fractions, and all it takes is 1 fraction, and the goal is to get rid of it. Now, some of you may have heard the term equivalent. Well, by multiplying each term by the LCD, we are creating an equivalent equation. A lot easier to solve. Okay, now the last or second part is when you have decimals. And because we're going to have story problems that deal with money, money is decimals, you are going to find that you are going to multiply each term within the equation by the smallest power of 10. Now, that's what the rule is, but there is a shortcut, and I will show you what to do because that's going to eliminate all decimals and make it a lot easier to find. And the hint is you want to use the term with the most decimal places. And when we get to decimals, I'm going to show you what that means. It makes life very easy because we're getting rid of fractions, we're getting rid of decimals, and then it's possible we could still have parentheses, which then builds on what we've been learning. Well, let's come right here. Okay. Now, notice right here. This is David. We have no parentheses, but we have fractions. Okay. This little three-way at the end has a denominator of 1. Our LCD. Well, if you take the 3, the 2, the 3, and the 1, what would be my common denominator for that set of numbers? It would be 6. Well, let me show you what happens. This is a term. I'm going to multiply it by 6. This is a term. I'm going to multiply it by 6. This is a term. I'm going to multiply by 6. But you gotta remember, everything is multiplied by the LCD. Even that 3 that was all by itself. Okay. Now, here's how it's going to work. Okay, and I'm going to see if I can insert a blank slide. Yeah, I did. Okay. Now, what you're going to do is you're going to take each term. And let me show you what I mean. This is my first term. That means that this is 6 over 1 times m over 3. I am cross-canceling to get rid of my fractions. I have 2m. Now, I'm going to take this term. And notice it comes behind the plus. This is going to be 6 over 1 times a half. When I cross cancel, this is going to give me plus 3. Here's my equal sign. Well, now I'm going to come right here. This is going to give me 6 over 1 times 2m over 3. Now, this is where you're going to have to be careful. This 3 and this 6 are going to cross cancel, and that leaves me 2 up here, but that 2 is multiplying by 2m to give me 4m. And lo and behold, 3 times 6 behind the plus is 18. I have just gotten rid of my fractions. Oh, how nice. Wasn't that a very easy thing to do? David said, eliminate the fractions. That's the first thing I did. Now, to help you, I'm going to take and rewrite this line on the next slide because I'm going to run out of space, so don't want to do that. Over here, I have 2m plus 3 is equal to 4m plus 18. Now, let me go back a slide. Okay, I am now going to do Aunt Sally. I'm not combining terms. I have a variable and a number, a variable and a number. So the first thing I'm going to do after I got rid of the fractions is I am going to subtract 4m from both sides. I'm going to subtract 4m from both sides. This is going to cancel. So on the right side of the equal sign, all I have is positive 18. But over on the left side, I have negative 2m plus 3. This is now our two-step equation. I am going to subtract 3. Negative 2m. This is canceling, and this is 15. I'm going to make dumpling, which means I'm dividing by negative 2. Now the m is equal to a negative. Now we put the negative with the fraction bar. It's 5 or 15 over 2 or negative 15 over 2. Notice I eliminated my fractions. The rest was easy. I just had to know what to do. Now, we're going to try another one, okay? This is where you're going to have to watch what you do because we're going to eliminate the fractions first. Okay. Now, this is where you have to recognize what is a term. Okay. This 1/9 m is a term. This 1/2 is a term. And this is what you have to understand. This is a term. The 2/9 is next to a parentheses. I'm not distributing yet. I have to eliminate the fractions. Well, my LCD for 9, 2, and 9. Now notice I'm not looking at the parentheses because that blue box is a term. The fraction is in front of the term. And that means I'm going to have 18 right there. Okay. Now, let's work this out. Okay. Here's my yellow term. I am multiplying this by 18, which is 18 times 1/9 m, and I'm cross canceling. This gives me 2m. Now, this plus is right here. Okay. Now, I'm going to take and multiply this second term by 18, which is 18 over 1 times 1/2. I'm cross-canceling to give me a 9. Now, the beautiful part is the parentheses 3m minus 2 is not changing. I am taking 18 over 1 times 2 ninths. I am cross-canceling. This is 1, this is 2. So the coefficient in front of my parentheses is the whole number 4, because this 2 is multiplying by this 2. But notice, this line has no more fractions. Isn't that beautiful? Okay. Now we're going to continue. Well, I'm going to go and show you how I'm going to distribute, because we're still at this first step. David has 3 parts to it, but there is an order. Fractions or decimals go first, then I distribute. And if you remember, distribute came in section 3.1, so it's something we've done in the past. We're now adding to what we've done. Now this gives me 2m plus 9. Now distribute 12m minus 8. I've now distributed. And that's going to bring me to my next slide so that we can finish the rest of it. Now notice I'm not combining terms here because I have a variable with a number, a variable with a number. I do not have 2 variables or 2 numbers on one side. So now what I have is 2m plus 9 is equal to 12m minus 8. Now again, this is my choice. I am subtracting 12m from both sides. This is going to cancel. Now I'm getting a negative 10m plus 9 is equal to negative 8. I am subtracting 9. This is canceling. Now notice here, I canceled the letters on the right. I'm canceling the numbers on the left. And this will bring me to negative 10m is equal to negative 17. I'm going to then make dumplings. I'm dividing by negative 10. This gives me m is equal to a positive 17/10. Or again, the solution set is 17/10. We are not making mixed numbers. Okay. Okay. Now, this is where it, I think, a lot easier with decimals than it is with fractions, because it's a game of decimals. Because the first step we're going to do is eliminate the decimals. Okay, now, this has 1 number to the right of the decimal. This has 2 numbers to the right of the decimal. This has 2 numbers to the right of the decimal. Now, if you had to make these into fractions, which I don't want to do, I would have 2 over 10, 15 over 100, 25 over 100. Well, the 100 is the key. I would then have an LCD of 100. Well, with decimals, it's real easy. What you're going to do is take this decimal place and you are going to move it 2 places, which means this 0 point is going to go away, and I have 20n. This decimal is moving 2 places behind the minus sign. This is 15. Now notice, I did not touch the parentheses. And then this decimal moves 2 places. The most decimal places I see are 2. So every decimal term moves that decimal 2 places. And now I distribute, which means I have 20n minus 15n minus 60 equals 25. Now, we haven't seen this step in the last couple of slides, but if you're going to notice, these 2 terms are on one side. Okay? And because they're on one side, and I wrote this purposely, I'm not going to deal with Aunt Susie because I have only one term. This step 3 gets canceled because I now have 5n minus 60 is equal to 25. There are not variable terms on either side. Now, we're down to the 2-step equation. I am going to add 60, which is going to give me 5n is equal to 85. And then my last step. And I'm going to add another slide here to make life easy. I now have 5n is equal to 85. Divide by 5. N is equal to 17. Or the solution set is 17. Okay. Now, let's do another one just so you understand decimals. Okay. This is a term. This is a term. This is a term. The first thing we're going to do is eliminate decimals. Well, if you look at term number 1, I just have 0.1, 1 decimal place. If I go to the middle term, 0.15, now I'm not looking at the parentheses. I'm only looking at the coefficient, where the decimal is. Well, that's 2 decimal places. But go to the other side of the equal sign. I have 3 decimal places. Now, because I have 3 decimal places, that's the maximum number of decimal places, which means this decimal is moving to the right 3 places. This decimal is moving 3 places to the right. And then this decimal is moving 3 places to the right. And just to make sure that you can see my 3 here. Okay, well, if I move the decimal on the first term, I'm going to have 1, 0, 0, x plus. Now remember, what's inside this parentheses, I'm not touching. That is going to give me 1, 5, 0, and this is 8 minus x. And then that 8, I'm not touching it. This is going to give me 1, 2, 5 times 8. I've eliminated the decimals. Well, now I'm going to distribute. Okay. This will give me 100x. Now, 150 times 8 is 0, 0, 1200 minus 150x equals, now 8 times 125 is 0, 0, and I think this is 1,000. 0, 0. Yep. Okay. Combine terms. 100x and a negative 150 is a negative 50x plus 1,200 equals 1,000. Okay. Well, again, this and Susie is eliminated. I don't have anything to combine, but I put it there just to confirm with you. I have only one variable. I have a number. I'm going to finish this by subtracting 1,200 from both sides. Now this is going to give me a negative 50x. Now this is going to cancel out, but this is going to give me a negative 200. Okay. Well, notice here, I want a positive 1 coefficient. Well, on my next slide, I have a negative 50x is equal to negative 200. I am going to divide by negative 50. Now, I want to show you a little trick. I'm going to take away 1 0. That's like dividing by 10. And that then gives me just this fraction, which is x is equal to a positive 4, because negative divided by negative is positive, or my solution set is 4. Any question with this? Does everybody see what I did? Now, you may have to look at these slides a couple of times and think about what I'm doing. But this is how you can solve any equation that's linear. Now, there's more stuff to do with different types of equations, but these are linear equations. Now, I'm bringing back this next slide because this is where we talked about it in 3.1, but we didn't really use it. Well, the reason is you got to have a whole lot of terms in an equation because remember, we've talked about 3 types of solutions. In 3.1 and everything up till now, we have had an answer, one solution. Well, now, because we're in 3.2, and toward the end of this course, and if you take 482, you are going to find that you're going to have many solutions or all real numbers, sometimes called infinite solutions, or you're going to have no solutions. It's finding these, okay? And again, here we go. I still have this acronym over here in case we need it. Now, first off, notice there's no fractions. There's no decimals. But I do have to distribute first. Well, this gives me 9p plus 4 is equal to p plus 8p minus 28. This 4 is multiplied by -7. Okay. Combine terms. Now, we're only going to combine terms right here because I have 2 p's on one side. Well, this will give me 9p plus 4 is equal to 9p minus 28. Okay. Now, this is where you're going to have to be careful because here, the p's are going to move. Okay. Now, watch what I get. When I subtract 9p from both sides, notice what happens. This p and this p are canceling. I don't have anything here. Look at what we have. You have a positive 4 is equal to a negative 28. Okay. Now, is this true? Can a positive 4 equal a negative 28? The answer is no. And when this happens, when you eliminate the p's by doing step number 3, all you have are the numbers left. This is an indication of a no solution. This is a no solution. Now, there's a couple of things you have to watch out because no solutions are going to come in a couple of ways. It is going to be an empty set. There's nothing inside those 2 brackets. But you're also going to see a circle with a line through it. Now, this symbol, some of you in mathematics, and I know in bookkeeping, we like to put zeros with a line through it. This is not bookkeeping. This is mathematics. If you give me a circle with a line through it, you are telling me that the algebra is saying no solution. Do not write your zeros with a line through it. If you have that practice, get out of it with algebra and any further math class, because a math instructor who sees a zero with a line through it means no solution. And we don't want a no solution here. That is most important. It's no solution. Okay. Now, some people like to write the words, but I will tell you that Pearson does like the empty set. That's just their symbol. But either way, the words no solution or the circle with a line through it indicates no solution. Now, let's try another one. Okay. Now, we're going to distribute. This will give me 3y plus 16 is equal to 5y minus 2y plus 16. This negative is multiplying by a negative. Now, combine terms. That's over here. This is 3y plus 16 is equal to 3y plus 16. Now, it's up to you. Do you notice what's on the left is the same thing as what's on the right? Now, if we continue down here, let's just say I subtracted 3 from both sides. I can do that. Well, notice, these are going to cancel. That's what this step did. What does it leave me with? 16 equals 16. This is not the same as our last slide, because the number 16 and the number 16 are on the same opposite sides. This is considered many solutions. Now, you could have seen it in the red box. That's called the identity property. Now, sometimes they write the word identity as an answer. Okay? Because that's what the red is. Now, I will also let you know that McGraw-Hill likes the answer all real numbers. This is your McGraw-Hill or Alex answer, all real numbers. And by the way, they put it in the brackets. Okay. This is what you're going to see. Now, you'll notice that if you use your student guide, they also call this an infinite number of solutions. Well, it's infinite because no matter what letter or number I pick for y, I'm still going to get the same answer. If I said y was 1, I'm going to have 3 times 1 is 3, plus 16 is 19. And then I'm going to do 3 times 1, which is 3 on the right side, plus 16. I'm still getting the same answer, 19. So the value of y is infinite. So another way of saying many is infinite. Okay. Now, we're going to finish up. Now, your book is going to give you these steps. Now, I always let you know because some instructors prefer to use this. I have a little bit of a tweet with it, but we'll see that as we go forward. But this is going to be steps for solving. And this, when they say applied, they're talking about story problems. Now, this is how Alex or McGraw-Hill want you to solve this. First off, they want you to read the problem carefully, more than once if necessary, until you understand it. Now, drawing a picture normally comes in when you have some type of geometry involved. And it can be a line, it can be a garden, it can be a fence. If geometry, draw the picture. Okay. Then you want to identify what you're being asked. What are you trying to find? Okay. Which means you're going to choose a variable and you are going to define it. Now, how you do that is something I'll show you when we get to the next section, 3.3, because these are what we call naked story problems. They're straight sentences that you're going to translate. You're taking English to algebra, and then you're going to solve it. Now, Alex likes to say, check your answer. And you'll notice that a lot of times the instructions may say, check your answer, but I don't really check too much because that does take time. And we did do the checking in 3.1. Basically, you're putting your answer in where the variable is. But this part with the story problem, interpret the solution. If you are looking at fencing, and you get a negative number, you should know you did something wrong. I can't have a piece of lumber negative inches long. Or if they say half a person or half a cat, can't have a fractional part of a person, because I'm going to ask you, what part of the fraction of your body are we talking about? So therefore, think about what the answer is in relationship to the problem. Also, a good example would be a cookbook. Cookbook, if you've ever opened one, you'll find that they're fractions being used, not decimals, fractions. So in a cookbook situation, you could have a fraction, but you wouldn't have a decimal in a cookbook. Also, money. Money is 2 decimal places, and hopefully you've heard that before. Without 2 decimal places, money is not correct. So think about and interpret what your answer is in relationship to the story. Now, as I said, these next couple of problems are what we call naked problems. The reason for they call them naked is that they don't have any situation. You're just taking the words in English and translating them. And you're translating them. If you remember this lovely sheet, we're looking at these phrases again. And these words come out to play. So hopefully you will have translated or copied or printed this particular worksheet as you do your homework. It is most valuable, or download it to your desktop. Now, let's use these phrases. And again, I want to draw your attention to this phrase, and this phrase. We are writing them from right to left. And as I mentioned, these phrases come from our Asian relatives on the globe Earth. We have mathematics as a universal language. Every culture has given us something. And these writing words in English, more than, left than, subtracted from, all happen to be from our Asian relatives. Right to left. And then don't forget, if two mathematical phrases are written back to back, you got to have the parentheses, which means we're distributing. Now, let's look at these phrases. Now, as you may see back here, I didn't indicate, but using highlighters are great things. And let me show you. 7 more than twice a number is 19. Now, this is what we're seeking. So I'm going to say X is equal to the number. That's what I want to find. Okay. Now you see this little is? That represents an equal sign. What comes after the word is going to go right there. Now, this is where the fun comes in. More than, we know, is an add, but it's got those asterisks, which means what's in front of the word more than is going to go behind the plus. What's in the is going to the front. We have just translated it. More than goes backwards. Now, I'm going to let you know, in Alex, in chapter 3, you could have written 7 plus 2x is equal to 19, and Alex in chapter 3 will give you that correct. But you don't want to use it. The reason is, as we go further, you want to start learning how to write it correctly. And now we're going to do Aunt Susie makes, Aunt Sally makes dumplings, which means we're going to subtract 7. Equal to 12 makes divide. X is equal to 6. And this is our number. Okay. Okay. Here we go. Find the number. X is the number. All right. Is. And notice, I haven't even read the story problem yet, but I found the is, and the is I know is equal. And then, here we go. 3 less than a number is 7. Well, that is told me I have an equal sign. What comes after the word is, I'm going to bring 7 right behind the equal sign. Now, less than means subtract. This is where you got to be careful. This 3 is going behind the minus sign. Now, a number is coming in front of the minus sign. Now, this one you cannot write the other way. More than is one of those ones they let you get away with in Chapter 3. But when you get to Chapter 4, I've had questions. Why are they marking it wrong now? Because you have to understand how it is correctly written. Might as well do it at the beginning. And then we finish. We add 3 to both sides. This is a one-step equation. X is equal to 10. And 10 is our number. Okay, 2 more slides. Okay, now this one, it gets a little hairy. Now, I'm going to read it all the way through, and notice I'm going to use highlighters. 7 less than 4 times a number is now the same as the number. Now, is the same as is a phrase that's going to be our equal sign. That number increased by 20. Find the number, which means we're going to say X is equal to the number. Now, right here, is the same as is my equal sign. Now, everything before that blue circle has got to be written to the left. Well, less than is minus. 7 goes here. 4 times a number is going here. Now, this is where the fun part comes in. That number is X increased by is plus 20. All of those words get translated. You're learning a language. Now, I've got variables on both sides. So that means the first thing I'm going to do is subtract X, which gives me 3X minus 7 equals 20. I'm going to add 7 to both sides. This gives me 3X. This cancels. 27. And then I'm going to make dumplings. Divide by 3. X is equal to 9. 9 is that number. Okay. Now, last slide for section 3.2. Okay. A number added to 5 is 4 more than 8. Find the number. Well, X is equal to the number. Go right to the word is. That's your equal sign. Now, everything back here is written to the right of the equal sign. But remember, more than is plus. 8 goes here. 4 goes here. Notice. Now, a number is X added to 5. X plus 5 is equal to 12. We're combining terms. All I got to do is subtract 5. X is equal to 7. That is our number. Find the phrase is, or in your brain, that's an equal sign, okay? Is the same as is also in that column if you want to add that phrase to it. This ends section 3.2. Yay! Bye!